All right, everybody. Today we're going to be taking a look at the second unit in the AP curriculum called Using Objects. Objects in Classes is something I teach in my 30S computer science course a little bit later in the terms of content. So I start with the 20S with things like variables, conditional statements, and loops. And then in the 30S, I go into methods and then arrays and then classes. But in the AP curriculum, this is the second unit of the AP curriculum. So let's take a look at what they have and take a look at this idea of using objects and how they present this content to you. We'll see how it relates to the previous content I've taught in my various computer science courses. So let's take a look at the way this unit is introduced. It's about classes, objects, and even the concept of methods introduced in this unit. You have previously covered this content in my Computer Science 30S course, as I mentioned. It has both methods and classes in it. As well, more advanced concepts in the unit called Advanced Classes in the Computer Science 40S course. All right, so classes allow you to store real-world data, is how the AP describes that. Oops. But that's essentially just saying modeling things in the real world. It builds on your ability to create expressions, code expressions, like those used with the built-in math class library methods or the string class in Java. You will know how to declare class-level variables or class-level objects, call methods from those objects, and how to even create your own classes eventually, and more advanced concepts like inheritance. Here you can see it in the AP curriculum. In the sort of big ideas section, it covers both modularity and variables and controls. So it's really covering all those things. How can we simulate election results using existing program code? How appropriate are variables to represent a remote control? How do games we play simulate randomness? These are the big ideas. You can also see this section 2 as a 2.1, 2.2, all the way up to 2.9. So we're going to go through each of those in the AP curriculum and how it relates. In terms of weighting for the AP exam, Unit 2 weights at between 5 and 7.5% of the overall exam weighting. All right, so let's examine topic 2.1 in the AP curriculum, which is the instances of classes. All right, so it's described as an object is a specific instance of a class with defined attributes. A class is the formal implementation or blueprint of the attributes and behaviors of an object. So we certainly covered this in Computer Science 30S. If you look around the real world, you can see objects, people, animals, plants, cars, buildings. Humans think in terms of objects. We possess the ability to use abstract thinking, to look at objects in a more abstract way, see beyond the simple to more complex views of objects. For example, we can objectify things in lots of different ways. When we look at a computer screen or a TV or a movie, we know we're looking at individual pictures in front of our eyes. When we look at people and cars or buildings, we don't necessarily see the individual bricks, we see the building as a whole. We can see a book and we can see not only pages collected into books, but paragraphs collected into pages, sentences collected into paragraphs, words collected into sentences, and letters collected into words. We can objectify things and make objects out of things, and then also collectively see those in abstract terms. All right, so this is where the word class can come in on a macro level, right? To put things into categories or to classify them, okay? So we can do this in our regular lives, classify things as friends and enemies and school and fun, etc. Google defines the word object as a noun as a material thing that can be seen and touched, and the word class as a set or category of things having some property or attribute in common, differentiated from others by kind, type, or quality. Okay, we can also divide classes and objects into animate and inanimate, things that move, things that do not move. This can be helpful when you take the idea of classes into programming something, for example, like a game where you can then divide your objects and classes into animate and inanimate objects within the game environment. But no matter what, classes have two things in common. They have attributes and they have behaviors. Now, those are the words that the AP curriculum uses, and I've used those words in class before as well, along with some other words that you'll see in this review coming up as well. Okay, so we're creating a class structure. Very simply put, I like to define it as a class is a collection of properties and a collection of methods. So that's at the most macro level. A class is a collection of properties and methods. Let's dig deeper into that. Properties are things about the class. And again, I can also use the word object, the class or the object. They're not exactly the same thing, but in the context of this level of the discussion, we'll say they're the same thing. So properties are descriptors. They describe the class. They're attributes. They describe things about that class. In English language arts, we'd call those adjectives, like the red cat, the hairy dog, right? Those are words that describe or are things about the attributes of the class. In English language arts, we would call the class the noun. Methods are things that a class can do. So those are actions, those are functions, those are behaviors. In English language arts, we'd call those verbs. Okay? So that's a way you can go a little bit deeper into the concept of a class. A class is a collection of properties and methods. Properties are things about it. Methods are things it can do. Okay, you can also see this. Okay. So, you can find an example of working with classes in the 30S. We certainly worked on it there. We certainly started building classes and then expanding on the concept. So let's move to AP topic 2.2. Creating and storing objects or instances, also known in a verb as instantiation. So here's how the AP curriculum describes this section. There's a lot here, so I'm going to go through them step by step. A signature of a class consists of the constructor name and the parameter list, and they're invoked to create objects that have the same name as the class. To me, this is some strange way to describe this, but that's the way the AP describes it. The parameter list in the header of a constructor lists the types of values that are passed and their variable names. These are often referred to as formal parameters. I actually don't know anyone refers to them that way, but the AP curriculum does. A parameter is a value that is passed into a constructor, which must be compatible with the types identified in the formal parameter list, are often referred to as the actual parameters. Constructors are said to be overloaded when there are multiple constructors with the same name but a different signature. Parameters are passed using call by value. Call by value initializes the former parameters with copies of the actual parameters. For me in class, I'll just pause here for a second, I would say that the more common term for actual parameters is the arguments, and the formal parameters is just the parameters. Every object is created using the keyword new, followed by a call to one of the class's constructors. Existing classes and libraries can be utilized as appropriate to create objects. Parameters allow values to be passed to the constructor to establish the initial state of the object. The keyword null is a special value used to indicate that a reference is not associated with an object. And the memory associated with a variable of reference type, in other words, a object level or class level variable, holds an object reference value, or if there is no object, the value null, the value is the memory address of that referenced objects. So we covered this in Computer Science 30S for sure, so you'll see that coming up here. The properties, the attributes, the adjectives are essentially written as variable data types, including even more complex types like arrays or even other classes. The methods, the actions, the behaviors, the functions, well, those are written with, as I said, parameters and potentially return types. The concept of object and classes now will differentiate between those words. They're definitely related concepts, but they're not exactly the same in terms of the definition. So Classes is what we conceptually put things into, whereas objects are specific instances of the class. So objects are specific and classes are general. So for example, food is a very general category or a general classification, but an apple is a specific type of food. It's a specific object of type food. So we can have specific objects under a general class or classification. So we can have apples and donuts and burgers under the class food. So in computer science, the class is the type and the object is the instance of that type. Okay, maybe this will make things more clear. In a line of code like string word equals apple, string is the name of the class, word is the name of the object of that class. And you can see that in the next lines where we have multiple lines of code where the class string is used each time, but the name or the identifier name of the object changes from word to person to place to thing. Okay? We have one class and multiple objects or multiple instances of that class. So here's a way to maybe visualize it. The class, the thing, the noun, the properties, the things about it, the descriptors, the variables, the data structures, the adjectives, the methods, the things the class can do, the actions, the functions, the procedures, the verbs, and then we take a class and instantiate it into an object of that class or an instance of that class. Right? So if we put this in a more sort of practical example, class person could have properties like name, age, gender, and living or dead. And class person could have methods like being born, dying, talking, and having a birthday. That would be an example. Okay? If we get closer to code, we would then have to take those properties or those adjectives or those attributes and define them as data types, right? Like, oh, maybe name will be a string, whereas age will be an integer, etc. And then we'll have to define the methods, right? Like, how do we write code to set a person to be alive, or to talk, to relay information, for birthday, to increase the age by 1, right? So now it's a matter of turning the concept into more of a code-based solution, okay? Many object-oriented programming languages exist, okay? C++, Python, Ruby, Smalltalk, C#, those all have object orientation and the concept of classes in mind. So that includes properties and methods. You have most likely done this with me through an IDE like NetBeans, which you can see here where I was setting this up, right? Then you would write the code, the name of the class, the properties, and defining them as code, essentially as global variables, and then defining the methods, which again, the way you write methods with return types and potentially parameters, and bracketing, defining the scope of the method. So you write a method signature, followed by a method body, etc. Okay, now, in that example, we wrote a method called born, which then I used to introduce the idea of a constructor method. Constructor methods are actually introduced even in the 20S course, although they're not called that, when you write a fun line in a code like random equals new random. And even at the time, as you write it, you don't really understand why you're doing it that way. And then later I come back to this to let you know that that method, random, is actually a method of the class random, and therefore it's what's called a constructor method, okay? Constructor methods are these special methods that are called when you instantiate a class. They're different from regular methods in 3 distinct ways. One, the name of the method matches the name of the class. So if you have a class person, you'll have a method called person, which means it's going to start with the same casing, the same upper-lower casing as the class. So classes, we usually start with an uppercase letter, and methods, we usually start with a lowercase letter, but in the case of constructor methods, we don't do that. We use the uppercase letter to define the method. That's generally a Java style, not necessarily transferable to other programming languages. But the most important thing about the constructor method is it has no defined return type, not even the word void. You intentionally leave the word void out to intentionally signal that this will be a constructor method. So you can see in our example, we rewrote the born method as the constructor for the person class, In other words, a person constructor. When a constructor method has no parameters, it's defined as a default constructor. So constructor methods are called or invoked when you take a class and instantiate an object. So a line of code like you see there, person, person equals new person, you see everything in that line. You see the name of the class, person with a capital P. You see the name of the object or the identifier object, person with a lowercase p. You see the keyword new, which calls upon new memory. And then you see the word person with a capital P followed by 2 round brackets. That's a call to the constructor method, specifically the default constructor method of class person. However, classes can have multiple constructor methods. In other words, you can overload the constructor method. Overloading meaning 2 methods with the same name but different parameters. So here you see another version of a person constructor method, which has a parameter, in this case the variable new name, which is then used within the body of the method to assign that string variable to the property or the attribute of the class. Now, this also brings up the concept of how do I name my parameters versus how do I name my properties, and it allows me to introduce the concept of the word this. This is a reference to what will be the object when you're defining the class. So you can use the keyword this to make an explicit reference to the, for example, the parameters can then refer to explicitly the properties of the class. And you see that with the person name, this dot name equals name, etc., which makes reference to the property rather than the parameter. Okay? And we did this through our examples in the 30S course. We also did it in the 40S course as well. Okay, so you can look back at lots of examples of this if you look back in our course content in both 30 and 40S computer science. All right, let's talk about calling a void method, which is section 2.3. Here's what the AP curriculum says. An object's behavior refers to what an object can do or what can be done to it, and is defined by methods. Procedural abstraction, what a fun term, allows a programmer to use a method by knowing what the method does, even though they don't know how the method was written. I describe this process as black box programming, where you can call a method without having to look at the method, right? But the AP likes to call this procedural abstraction. A method signature for a method without parameters consists of the method name and an empty parameter list. A method signature for a method without parameters consists of the method name and empty parameter list, in other words, empty round brackets. A method or constructor call interrupts the sequence of execution of statements, causing the program to first execute the statements in the method body before coming back to the place where the method was called. Once the last statement of the method or constructor has executed or a return statement is executed, the flow of control is returned to the point immediately following where the method or the constructor was called. Non-static methods are called through objects of the class, and the dot operator is used along with the object name to call upon those non-static methods. Void methods do not have a return value and are therefore not called as part of an expression. Using a null reference to call a method or access an instance variable causes a null pointer exception or error to be thrown. So we covered this in Computer Science 30 and Computer Science 40S, the classes and the advanced classes unit. Let's take a look at some of that content. So let's first start taking a look at the breakdown of what methods are. Programming involves breaking up a task. So in software development, breaking up a task into logical modules or logical units is useful. This starts at the level of creating methods or functions or procedures. And as human beings, we break down problems all the time. So in the Computer Science 30S, I use an example of boiling water and how you could break that down into tasks. Then I sort of pseudocode that out, how that could be done using pseudocode, to kind of see how that would go. How, you could go that way, and you could, have find pot, go to find pot, which goes to move to, comes back to grab, jumps to grab, comes back to move to, and eventually finishes find pot and goes back to fill with water, right? So that's a way you can kind of trace through method executions. Methods call other methods, or calling a method, breaking down, decomposing a problem. Think of it as instead of writing one problem, solving one problem, you're breaking it up into solving multiple smaller problems. So methods can perform tasks, they can return values. You as a programmer can define these methods and write them. And there are a lot of methods that are built into programming languages like Java, and you can therefore call either built-in methods or methods you write yourself. So when you write a method, there's a way to write it in the signature line, including defining public or later private, and then possibly static, possibly a return type, naming the method, defining curly brackets with any potential parameters, and then curly brackets to define the body of the method. Here's a simple example we did in the 30S course, and then we would expand on that, talk about how it's called. Method like makestars would be called. And then we could even introduce concepts like static and how static can be applied to different things, including methods. And essentially static means shared, so that the static, in this case method, belongs to the class rather than belonging to the object of that class. Okay, and how that static could apply to data structures as well. So here you see an example of a static variable, which would then be shared amongst all the objects of the class. And then it could be applied to something like a constructor, as we did in the 40S course. A static method like this, where the static keyword or modifier word is added to the class signature line, the method signature line, would then mean you could call upon that method not only from objects, but also call upon it from the class itself, because the method is shared by all objects of the class and by the class itself. You can also see in this visual how the variable, which is a static variable total students, is shared by all the objects, right? So each object has their own individual name, age, etc., but they all share upon the variable total students because it was defined as a static variable. That was done both in the 30S course, a little bit about methods, and in the 40S course, specifically about things like static. All right. AP Content 2.4, calling a void method with parameters. Let's continue with section 2.4, calling a void method with parameters. This is more about methods, but the AP defines this as a method signature for a method with parameters, consists of the method name and the ordered list of parameter types. Values provided in the parameter list need to correspond to the order and type in the method signature. Methods are said to be overloaded when there are multiple methods. So that's what's defined in the AP curriculum. Let's take a look at how we've reviewed this content before. So when I taught methods in the 30S course, I talked about how methods could require data in order to complete its task. That data is passed to the method through the parentheses, through the brackets, and this is known as a parameter. Okay, I've said how you've already called methods doing this, where I've used the idea of black box programming, where you can use methods without necessarily looking at how they work, right? And I mentioned dialogues like show input dialog, show message dialog, use that sort of process where you call upon the method, pass it an argument into its parameter without really knowing how the method works, yet you still get the outcome and the result that you want. When you write your method and you define parameters, you can pass any type of data that the method requires in order to function. So we made an example of a method called makestars, which now takes a parameter like a number and will write up that many number of stars as part of its execution. And then different ways it's called, where the argument is passed over to the method, whether that argument, as long as it fits the requirement of the parameter. So if the parameter requires an integer, as long as you pass it an integer, the method can accept it. And it can even be more complex things like equations or expressions can be passed as long as the outcome of that expression is of the defined type of the parameter. You can pass more than one thing to a method, and in that case, the parameters are separated by commas, so it could be an integer, it could be a character, but then when you call the method, the order in which you call the arguments has to match the same order in which the parameters are defined. So order does count. Okay, you can also overload methods, which means you can create more than one method with the same name as long as they have distinctly different parameter lists. So here you can see one of the first examples of that. 3 versions of the method makes stars. One has an integer, one has a character, and one has an integer and a character. So those are 3 very different parameter lists. And then when they're called, the argument order will determine which version of make stars is called because of the parameter list. And that's called overloading. So we did this in our 30S example. You can find different versions of that if you look back. Let's move on to 2.5, calling a non-void method. So this is defined in the AP curriculum as non-void methods return a value, the same type as the return type defined in the method signature line. To use the return value when calling a non-void method, it should be stored in a variable or used as part of an expression. So because the method is returning something, you want to do something with the value it's returning, like store it in a variable or make it part of a larger expression. Okay, here you can see a simple example of a method called cubeof, which returns type double. You can see in the main method where cubeof is used as part of a print line statement, and therefore the value that's returned will be concatenated onto the print line string literal that's outputted by the print line method when it's called. That's what a non-void method essentially does, okay? A void method doesn't return anything, so that's why the word void is there. And you can get more complex with things like compound statements, which we looked at. And this leads into commenting the methods. So methods themselves should be commented properly, including the purpose of the method, any preconditions, which essentially would be any parameters, any post conditions, which essentially is what it returns, and potentially even any dependencies, or in other words, does this method rely on another method that's also called within it. So that's just a way to think of generally how you could comment a method. Although most programming languages, most modern programming languages, including Java, have their own documentation style. In Java, it's known as Java Doc. Okay, C# has its own style, etc. And you can see that we work that into how we studied this when we did our examples, writing code in Java, using NetBeans to help us write the documentation or the comments for each method. Okay. So that's a little bit about methods and the commenting and documentation of methods. Now you can get deeper into documentation of things like classes and other types of Java documentation style. And Java documentation can be related to things like HTML and generating actual documentation for your code. But that's generally not something that the AP curriculum focuses on too much. When you design a method, you should use good programming techniques, the same techniques you use in problem solving in general. Analysis, design, coding, testing, debugging, documentation, and maintenance. So analysis, in the context of methods, what is the method supposed to accomplish? What problem is it solving, right? Don't overcomplicate this. Don't make it solve too many problems at once. Does your method require information passed to it? If not, then maybe it has no parameters. Does my method need to return something? If not, maybe it's a void method. These are things you can start to consider as you design your method. Once your method's designed, you then would keep in mind things like, does it perform a task? Does the name of the method describe that task? Does the parameter names make sense? Are they descriptive of what they're for? Is your method too long, or should it be divided up further into more methods, using more of a top-down problem-solving approach? Okay, when you write the code, again, you can make sure you're writing good code. You can do what's called stub your method, just test it quickly. You could then write what's called driver code to really put into the testing of your method. Testing is important. Make sure that if your method does one thing, that it's doing it well, it's doing it properly, and any potential errors have been handled. Okay? Documentation, which although I have it listed as the last step, is something you want to do throughout, not only commenting within the method body, but also doing the proper Java documentation for the method itself, which we've already covered. You can see that we did this in both 30S and 40S, writing tons of methods, commenting them with parameters, without parameters, with return types, without return types. All right, let's move on to AP section 2.6. 2.6 is defined as string objects, concatenation, literals, and more. Okay? So, string literals, or by calling the string class constructor. String objects are immutable, meaning the string methods do not change the string object. String objects can be concatenated using the plus operator or the addition operator or the addition equals operator, resulting in a new string object. Primitive values can be concatenated with string objects, causing implicit conversion of that value into a string object. Escape sequences within a string literal include the forward slash, and then a special character like a quote, a second forward slash, or an N, which could create new line values, which we covered in the Computer Science 30S course. Okay? Okay, so the string data type built into Java can hold strings of data and come with built-in functions. String data types are declared with the word string using a capital letter, as it is a class level object. And you can concatenate or join together strings using the addition operator or the plus sign. Okay? So here you can see just a quick example of that in code, and then we dig deeper into that, and then we also could convert data types like integers, or pardon me, string data types into primitive types like integers using a parsing process, which you can see here. Or you can parse into floats, you can parse into doubles, and other primitive data types. Here you can see some of that and some of the string built-in methods, such as the charret method and the length method. We explored a variety of these in the 30S course content. Okay. We also explored early in the 30S course some of those escape sequences, like the new line character and the quote and stuff like that. We did it as part of simple string literals in simple system.out.println statements. So you can see examples of that early in our 30S example. All right, section 2.7 of the AP curriculum dives deeper into string methods, and it says that application programming interfaces, or APIs, and libraries simplify complex programming tasks. Documentation for those APIs and libraries is essential to understanding how they work, essentially the attributes and behaviors of the object of a class. Classes in the API and libraries are grouped into packages, and the string class is part of the java.lang package, or language package. Classes in that package are available to your Java code by default for the Java language. The string object has index values from 0 to length -1 in an indexing system, very much like the array indexing system. Attempting to access outside that range will result in an index out of bounds exception or a running out of bounds error. The string object can be concatenated with an object reference, which implicitly references the object's toString method. Now that's a complex line to put in there, but that just means that the toString method would be called by default when you use a string object, or you use an object that is being used with a string object, so it would automatically concatenate it as a second string object. String methods and constructors, including what they do and when they're used, and a string identical to the string element substring at a position can be created by calling the built-in substring method of the string class. So in the 40S course, I talk about what packages are. So there's a little bit more you can read about what a package is, how it's kind of like a directory or a folder structure. I talk, as I've already done in previous reviews, about the object class as the parent class in Java and how it has built-in methods, including one of those being the toString method. I talk about the addition, subtraction, division, multiplication, and even the modulus operators as part of, for example, the math library and how it's used in that way to call upon methods of that type. And you can see lots of examples of this in both the 40 and the 30S content linked to here in this presentation. All right, moving on. Section 2.8, wrapper classes, integer and double. So I've already been talking a little bit about that, but the integer class and the double class, notice the capital I and the capital D, are part of the java.lang or language package. So in other words, they are built into the Java programming language. You do not have to import them. Integer methods and constructors, including what they do and when they're used. Double methods and constructors, including what they do and how they're used. A term called autoboxing, which is the automatic conversion that the Java compiler makes between primitive data types, like lowercase I integer and lowercase d double, and their corresponding object wrapper classes, which would be capital I integer and capital D double. The Java compiler applies autoboxing to a primitive value. So primitive int can become a class level int or its wrapper class. Unboxing is the automatic conversion of the Java compiler makes from the wrapper class to the primitive class. That's going the other way. Okay? And the Java compiler applies unboxing to a wrapper class automatically. Okay. So here you can see at various times through the 30S course talking about integers and doubles and how they are, and then converting from integers and doubles from strings, and casting from integers to doubles and doubles to integers, and even include floats and shorts and stuff like that in there. So you should be familiar with casting and parsing in that way, okay? In the 40S course, we dug deeper into memory allocation, how something like an integer is allocated, how something like an array is allocated in memory, how something like a class level object is a data structure, a collection of memory addresses and memory content, okay? We looked at this at a macro and a micro level in terms of the addressing and how it relates to memory and stuff like that. So hopefully, having taken the 40S course, you have a strong sort of understanding of how memory works when we're dealing with things like variables, how there's the identifier, the name of the variable, or the address, and there's the content. Those are two separate things, and the identifier references or is linked to the content. So we refer in code to the identifier name, and then we assign it content. We can change the content, things like that, right? Taking it up to things like classes and arrays and all that, we look deeply at data structures and how that relates to memory. And by looking at that memory, I hope it gives you a better understanding of variables and classes and how they kind of work in code. All right, moving on to AP topic 2.9, using the math class. So we've already been talking about this, but static methods are called using the dot operator. The math class is part of that lang or language package. It contains only static methods including what they do and when they are used, and the values from math.random is one of those methods, can be manipulated to produce a random integer or a random double in a defined range. Because random stuff is cool. All right. So here again, you can see that same slide again about the math class and how it can be used for things like absolute value or powers or square roots or even logarithms, and as well random values. And then how random values can be manipulated using things like formulas and parameters to generate random numbers in specific ranges. All right, let's summarize this unit. So the AP curriculum defines section 2.1 to 2.9 under the general topic using objects for unit 2. We covered all the concepts from 2.1 all the way through to 2.9. There was a big variety of topics there and a lot of content. You had covered it all in Computer Science 30S and Computer Science 40S. But just wanted to make sure, here's an example of a type of question you could encounter, in the AP from that content. So let's just take a quick look at it. Consider the process words method. Assume that each of its two parameters is a string of length 2 or more. So we have string word 1, string word 2. Then you see the method body. Create a string str1 by taking word 1 and pulling the substring from 0 to 2. Make a string called str2 by taking word 2 and pulling the substring from spot 0 up to word 2 dot length minus 1. Then create a third string called result by concatenating string 2 followed by string 1, or str2 followed by str1, and then outputting from that string result the index of str2. So it's got a lot going on in that question. Okay, so the first string str1 is built from word 1 by drawing upon 0 up to index 2, but not including index 2. The second string, str2, is built from the second parameter, word2, starting at the index, which is the length of the string, -1, okay, which means it would only grab the last character of that string. So if we passed words like apple and cat to this method, str1 would be AP, just A and P, and str2 would just be T, the last character of that string. Therefore, the result would take the last character and concatenate it to 2 characters from the first string. So we'll be looking at a 3-character string, right? The first character would be from string 2, or str2, and the last 2 characters would come from str1. Okay. Now, when the output uses index of, it's searching for the result, okay, result being tap, in str2. So str2 was cat, okay? And so the correct answer here is going to be A. It's going to find it at value 0, okay? Another example of a AP type question that uses the random number formula. And again, this is a pretty tricky question. So if you go through this question and you sort of apply things like a random number formula and you examine the different ways this is called, you can see that eventually that if you work through this problem, the correct answer here would be option D. All right. Then one final example here you can see here, and I'm not going to go through it in all detail. This video is already pretty long. You see a vehicle class, okay, you see a classify method, and you can see how I broke it down to eventually show that the correct answer in this case would be answer E if you break it down. Okay? Take some time later to look back at this video if you're having trouble with that question and look at it in that way. And that concludes my presentation on this. I'll just jump over real quick and just go through a little bit of this here with you guys. This learning objectives, which you've already seen, and the vocabulary. So this would be useful for you to go through all that vocabulary and really get a feel for what the AP is looking at. Again, you can look through this stuff in terms of what a class is. We've already covered that. You could even sort of look at this in more detail with specific examples, even things like UML diagrams, if that's useful to you, although that's not formally part of the AP curriculum. You could, again, look at things like constructor methods, the this keyword, overriding methods, the object class, the static modifier, and that would kind of go over a lot of that content. So feel free to go into various resources, including this video, to find that, or contact me if you have any questions. All right, like and follow, and have a great day, everybody.